Good morning, class. Happy to have you here. Hopefully you're happy to be here. Even if not, I'm still happy you're here, even though I'm actually not here right now. Okay, I'm currently flying back from Colorado, like I told you in class last Thursday. But today we're going to be doing section 1.5. So our objective, if you look over the sideboard real quick, is SWBA. Students will be able to classify and use angle pair relationships. So we're first going to talk about an angle bisector. We had segment bisectors before a couple sections ago, and it's something that cut a segment in half. Well, same idea. An angle bisector is a ray that divides an angle into two congruent angles. And if you want, you can write out the word congruent, but I'm not going to. Okay. So it divides an angle into two congruent angles, so kind of like a segment bisector, but instead of cutting a segment in half, it cuts an angle in half. And instead of being a lot of different things, a ray, line, plane, etc., this has to be a ray. And over to the right, we actually have an example of an angle bisector. In this picture, ray AC, okay, ray AC here. Ray AC is the angle bisector of this big angle, okay, of angle DAB or DAB, okay. And I did that on purpose, okay? Angle AC is, in fact, the bisector, okay? So it's cutting it in half. So what that would tell us is that angles BAC or CAB, if we follow the letters CAB or BAC or CAB, either one, this part of the angle is going to be congruent to angle CAD or DAC, either one, okay? So it's just saying that because ray AC is an angle bisector, these have to be congruent. Now we can show congruence among angles. We can show angles are congruent by the number of arcs. So I'm going to put one arc in both of those, and I'm going to erase some of those other strokes here. And if I put one arc in both of these angles, that shows that these angles are congruent, and that ray AC, A, starting at A and going forever in C, is the angle bisector. So we can use an angle bisector to find the measure of multiple angles here. For example, the measure of angle CAB, the measure of angle that left half of the angle, would be equal to the measure of the angle of the right half as well. So it'd be equal to the measure of angle DAC or CAD. Once again, the order of those first and third letters does not matter. But the middle letter, the vertex, has to be the same every time. I can't move. So the measures are equal because they're congruent. Another thing is we could say, hey, if we take the measure of angle BAC, one of the small ones, the one on the left, plus the measure of the angles DAC, the one on the right, we're going to add them together, and we're going to get the measure of the entire thing, angle DAB. And yes, I did do DAB on purpose again. Okay. So once again, if we add the two parts, we'll get the whole thing. Now, we can say that since they have the same measure, both halves have the same measure since they are half, it's bisected, we can take 2 times the measure of angle CAB, and we'll get the whole angle DAB, okay? If CAB has to be half, this has to be half of the entire thing, we can just double it to get the whole thing. Or we could also double the other part. So instead of doubling CAB, we could double DAC. So we could double the measure of angle DAC, so we can take 2 times that. We'll use that in a moment. But for now, we'll continue on to the next slide. We have an example here, okay? Example here on the left side of the page. Ray AC bisects angle DAB. So kind of the same setup here. Ray AC is bisecting. Solve for x and find the measure of angle DAB, the big angle, if angle CAB is equal to 2x plus 10 and angle DAC is equal to 3x minus 20. Well, first things first, I'm going to label some things. So ray AC bisects angle DAB. So ray AC bisects the big angle. Well, we said at the last slide, bisects means it cuts it in half, okay? It's going to make it into 2 congruent angles. So we know angle CAB here on the left is going to be congruent to angle DAC. So we can mark that with 2 arcs, 1 arc on each, total of 2. Then I can label the measures. We know angle CAB has a measure of 2x plus 10, and we know angle DAC has a measure of 3x minus 20. Now, because these 2 angles are congruent, we should hear congruent, and we should instantly think, oh, we can set them equal, okay? Congruent, set equal, congruent, set equal. Okay, they go together. So I can set these equal. 2x plus 10 equals 3x minus 20. Once again, we can set them equal because they are congruent. Now this will help us because we'll be able to find x, which is one of our goals, to solve for x, and we'll also be able to plug that back in to find the measure of angle DAB. So we'll solve this equation now. We want to get our x's together, so I'm going to subtract 2x from both sides and get 10 is equal to x minus 20. I'm going to add 20, and I'm going to get 30 is equal to x. So I did part of what I wanted. I wanted to solve for x. So now what I have to do is the other part. I need to plug it in to find the measure of angle DAB, the big angle. Okay. Now, we have a couple ways we can do this. We can plug it into one of the two angles that we're given, the 2x plus 10 or the 3x minus 20. We can plug it into one of them and double it. Or we can plug it into both and add them together. The reason why either would work is because either is supposed to be half, so we should be able to double either one of them. But it's a little bit safer to plug into each one because that helps us check our work. Because if we end up getting the same thing for both, that means we did something right. So I'll plug in 30 over here and say, okay, 2 times 30 plus 10. Well, 2 times 30 is 60. 60 plus 10 is 70. So we know this measure over here is 70. I'm going to plug in 30 over here as well. 3 times 30 minus 20. 3 times 30 is 90. And subtract 20 from that, and that would end up being 70. So it's a good thing they end up being the same. So we add them together to get the big angle measure of angle DAB. Measure of angle DAB ends up being 140 degrees. And these two things are the answers because we wanted both x and measure of angle DAB. Alrighty, continuing on, we have another example. It's similar, but with a twist. So once again, same setup. Ray AC bisects angle DAB. We should know right now, oh, these are cut in half. We can mark those two small angles as congruent. Next, we're solving for x and finding measure of angle DAB. Same thing as last time, but this time we know angle CAB is x plus 5. I'll label that. And angle DAB is 4x minus 12. Now, don't be caught off guard. This is not DAC. It's not just the right half of the angle like last time. This time, it's the entire thing. We're saying the entire thing here is 4x minus 12. So we have to be careful here. We're not given the other half. So we might think for a second, what do we do? How do we set this up? What we would end up doing is we can say, we had a couple slides earlier. If we double one of the measures, we get the big measure. And we'll do just that. So we'll double one of the measures, we'll put 2 times one of the measures, x plus 5, that we're given, the small one. And that's going to equal our big measure, 4x minus 12. Because if we double half of the whole angle, we'll get the whole angle. I'm saying if you double half of the big angle, you'll get the big angle. So to start off this equation, we'll distribute our 2, and we'll do 2 times x and get 2x. We'll do 2 times 5 and get the 10 equals 4x minus 12. We'll subtract, you could subtract the 10 first, but I'll start by subtracting 2x. We get 10 is equal to 2x minus 12. Add 12. 22 is equal to 2x. Man, Taylor Swift would be proud of us there. Divide both sides by the 2. And our x is 11. Well, that's half our answer. We wanted to find x. Now we need to find the measure of angle DAB. So here we can plug it into either again, but if we plug it into the x plus 5, we're going to have to end up doubling it. Or we can just plug it into the big one already, angle DAB, since we're already given that measure to be 4x minus 12. So I support plugging it in there. So 4 times 11 instead of 4 times x plus 12. Or excuse me, not plus 12, but minus 12. 4 times 11 is 44, and you subtract 12 from that, that'd be 32. So the measure of angle DAB, or DAB, is equal to 32 degrees. So x was 11, and the measure of angle DAB is 32 degrees. We could check our work if we would like by plugging it in into our small one, our x plus 5, and saying, okay, instead of x plus 5, it's 11 plus 5, it's 16. And if we were to double 16, if we were to take 2 times 16 here, we would get 32. Continuing on, we're going to talk about adjacent angles. Does anyone know what adjacent means, okay? You might be saying something similar like next to, or with, or by, okay? I'm going to go with that next to, okay? So if two angles are adjacent, they're next to each other. So adjacent angles have a common or shared side. When we say that's common, we're saying that it's a shared side there. So don't forget, a side is one of the rays that make up an angle. And it will also have a common vertex. So over here on the right side, we could say, hey, we could have, pretend there's a point on here, we can make this point C, point W, and we can call this ray CW. So the common shared side here could be ray CW, and I just added those in out of thin air. Okay. And our common vertex could be point C. Okay. And just because two angles are adjacent does not mean they are congruent, okay? Let me show you an example. So if I were to have this, looks like a straight line, do that. These two angles are adjacent, but they're not congruent. They're not the same measurement. They don't even look close. But they're adjacent because they share this vertex. Okay, they share this vertex, and they share this side. Okay, so they have that in common. Next, we have vertical angles. Vertical angles, don't just think of a vertical jump. It's actually a little bit different. So with vertical angles, they share a vertex. Vertical angles share a vertex. Okay, vert there. Okay, vertical, vertex. In this case, they all share vertex E, point E. The sides of vertical angles, the sides of vertical angles make two straight lines. And they are always across from each other. The angles are always across from each other. Now, a fact we know about vertical angles is they are always, all caps, they are always congruent. Once again, you can write that out if you would like. The spell out would be like this. Let me show you an example of vertical angles. So here on the left and the right side here, we see a pair of vertical angles. Angle FEI, and angle GEH would be a pair of vertical angles, okay? They share the vertex E. Their sides make two straight lines. Look at ray EI and ray EG. They make a straight line, okay? Let me highlight that real quick in my marker. Okay, ray EI and ray EG will make a straight line. Additionally, ray EF and ray EH make the second straight line. And they are across from each other. They're not adjacent, they are across from each other. And so they are vertical angles and thus always congruent. Another good way to look at vertical angles, and I want you to write this in, I really want you to write this in, is that vertical angles will make an X. They'll make an X. So if we kind of look at here the way the lines are set up, it looks like they're making an X together. Okay, it kind of looks like an X or a crossbone, so to speak, like you're throwing the bones in football. Now, additionally, besides those other two on the left and right vertical angles, we have another pair of vertical angles at the top and the bottom. Angle FEG and angle IEH in the blue there, 134 degrees, and they're also congruent. Continuing on, here's an example using vertical angles, okay? So these make an X here. These angles on the left and the right will make an X. And they share this vertex, and their sides make two straight lines, and they're across from each other. So these angles are, in fact, congruent. Okay, they are, in fact, congruent. So once again, when we hear congruent, our mind should be going crazy saying, oh, I need to set them equal. So we're going to set them equal. 3x plus 20 equals 10x minus 15. And we're asked to find x, so we're going to work on that. So I'm going to subtract 3x. Get 20 is equal to 7x minus 15. You might be thinking, Mr. Coster, you're going too fast. Or I would like an opportunity to work it out and then check it against his work. Okay, well, you can always pause the video or rewind the video as you need to accommodate those things. Next, I'm going to add 15 to both sides here and get 35 is equal to 7x. Last but not least, I'll divide both sides by 7, and x will be 5. And we're all done. If we want, we could check our work, plug them back in, and make sure they get the same thing. Both angles would end up being 35 degrees, which are the same. But we don't have to do that. Really, all we need to do was find our x. Next, we have linear pairs of angles. We learned about vertical angles, we learned about adjacent angles. Now we're going to talk about a linear pair. If we look at the word linear, we kind of see the word line in there. We talked about that earlier this semester. And pairs means two. Pairs means two, okay? So we're talking two angles that make a line. That's what I want you to think. Two angles make a line, okay? So to be linear pairs, they have to be adjacent. They have to be next to each other. Share that vertex and share that side. And they also have to be supplementary. Supplementary. Now, this is a new word to us in geometry, okay? You might have heard of supplements, like maybe dietary supplements. If you went to the doctor recently, wherever, you might get asked, hey, are you taking any supplements? What that means is just things that are adding on to something. So in this case, in that doctor example, they're things that are adding on to your diet. So maybe that's protein powder, maybe that's vitamin C, whatever it might be, okay? You're taking some supplements. Supplement just means they're adding on to it. So in this case, we have this little bullet here that says it adds to 180 degrees. So when two angles are supplementary, they add to 180 degrees. And that makes sense with two angles making a line, because the line is 180 degrees. So here on example 5, when we're asked to find x, and we're told 8x minus 16 is the left angle, 5x plus 1 is the right angle, and it looks like these make a straight line, they're a linear pair, okay, because they're adjacent, they share this vertex, they share this side, and they add up to 180. So what we're going to do to solve our equation here is, since they add up to 180, we're going to add them to 180. Really creative, isn't it? Okay. So 8x minus 16 plus 5x plus 1 equals 180. So once again, we're going to add them to 180 because they're supplementary, which means they add to 180. We're going to combine like terms. 8x and 5x give us 13x. Negative 16 and 1 gives us minus 15, or negative 15. That's still going to equal to 180. Add 15 to both sides. 13x is equal to 195. Divided by 13. And x is 15. We don't have to go any farther if we don't like. You could go farther and check your work and make sure they add to 180 after you plug them in. But we don't have to. We're just finding x to be 15. Next, we want to identify some angles, okay? So we've gotten some different things thrown at us. We've talked about linear pairs and vertical angles, talked about adjacent angles. Right now, I want us to clarify between linear pairs, vertical angles, and neither, okay? And so in this picture, we have 5 angles. They're numbered 1, 2, 3, 4, and 5. Now, for letter A, for angles 4 and 5, angles 4 and 5, I would say that these are a linear pair, and I want you to try these on your own. I'm going to shorten linear pair to lin pair. But I want you to try these on your own before I go through and do all of them for you. So if you need to, pause the video and do them real quick. So 4 and 5 are a linear pair. They are adjacent, and they make that straight line, okay? They add to 180. Two angles together make a straight line. Letter B, we are looking at 4 and 3 angles, 4 and 3. I would say that those are, in fact, vertical angles. I'm going to shorten that down to vert and do the angle symbol. 4 and 3 are vertical angles because they make that x. You can see them here making the x. The more formal definition is saying that they share the vertex, they're opposite each other, and then their sides make a straight line here, straight line here. Next, we have angles 2 and 4. Angles 2 and 4. These are actually going to be neither. Some people like to think that they may be a linear pair because they kind of make the line together, but they're not adjacent because angle 1 is right between them. So because angle 1 is being a third wheel, these are not a linear pair. These are neither. They do not add up to 180. They're not a linear pair, or they're not adjacent, not a linear pair, and they are not right across each other, opposites. And their sides don't make an X. This side would, but this side doesn't, and this side doesn't. So they're not vertical angles either. Last but not least, we have angles 1 and 5 for letter D. These are also going to be neither for the same reasons. So they're not next to each other, so they can't be a linear pair. And they're not vertical angles because if we look at the X, okay, straight line's up here, but this side of 1, no. This side of 1, no. So it doesn't work, okay? So these do not make an X. Their sides do not make two straight lines. Continuing on. Complementary angles. Okay, complementary angles. What do we know about all complementary angles? This is a new word to us, okay? Complementary angles mean that they add to 90 degrees. So it's not 180, but they add to 90 degrees. So an example of this in a picture, there's a lot of them that could be. This is one of them. Okay, you have an angle cutting through, and it doesn't have to be exactly in half. If you look, mine isn't exactly in half. As long as any two angles add up to 90. One could be 20, one could be 70, for example, okay? Add up to 90. If you look over at the far right side of the room, there's a poster that says complementary angles. It's my favorite poster in the room, okay? You should read it. It's a pretty good joke. If we're talking about supplementary angles, though, what do we know about all supplementary angles? They add to, not 90, but 180 degrees. For a picture on this one, you can just draw a straight line, or mostly straight line, and then put an angle anywhere in here. These two angles then would add up to 180, thus being supplementary. We're going to continue on, just a few more examples, and then we're going to be done here, okay? So, on example A, find the missing values and angles. Name the angle pair relationship you used. So on angle A, we can see we have two angles here that make a straight line. So I would say, okay, the angle pair relationship is probably going to be a linear pair. And we're asked to find x and the measure of these two angles. Now we're not given labels, but let me put them in here, okay? Angle A, B, D, and then angle CBD. So you may want to put those points on your paper as well. Since these are a linear pair, they add to 180. So what we're going to do is we're going to add them to 180. 2x plus 15 plus 3x minus 5 equals 180. Combine like terms, 2x plus 3x is 5x. 15 minus 5 is plus 10. That equals 180. Subtract 10. 5x is 170. Divide by 5 and get x is 34. We can plug that back in to figure out our measure of angle ABD. So we'd have 2 times 34 plus 15. 2 times 34 is 68. 68 plus 15 is going to be 83 degrees. Plug back in over here on the right side. 3 times 34 minus 5. 3 times 34 is 102. 102 minus 5 is 97 degrees. One thing we should notice about these two angles is they add up to 180. 83 and 97 add to 180. That's a good sign. Let's look at example B over here on the right-hand side. Example B, we have a couple different angle pair relationships we're going to use. So we're given that this angle over here is 26 degrees. Now that appears to be vertical angle with angle B. You know vertical angles make an X, and these definitely do make an X. Okay, and they're on opposite sides of each other, right? They are also always congruent, so because this is 26 degrees, measure of angle B has to be 26 degrees. To find either angle A or angle C, either of them, we could say it's a linear pair. It's a linear pair with our given angle of 26, or the angle we found, angle B. They're linear pairs, so they have to add to 180. So we can take 180, subtract our 26, and we have to get the rest of the angle. Okay, so there are angle A and angle C both. Well, when you subtract that, we end up getting 154. And they both should be the same thing. They are the same thing, but they should be as well, because they are also vertical angles with each other. On to the next one here. Letter C. These look to be vertical angles as well. They make an X. They're opposite each other. Vertical angles are always congruent. We should hear congruent and think, I'm going to set them equal. 3x plus 13 equals x plus 25. Let's subtract by x. Subtract by x. 2x plus 13 equals 25. Subtract by 13. Subtract by 13. 2x is equal to 12. Divide both sides by 2, and x is 6. Let's figure out the blue angle and the green angle. Anyone that might be colorblind, blue is the one on the left, green is the one on the right. Blue angle, plug 6 into this, so 3 times 6 plus 13. 3 times 6 are x plus 13. 3 times 6 is 18 plus 13. That's going to be 31 degrees. Well, we know our green one should be the same, but let's check. 6 plus 25. Yep, that is 31 degrees. Last but not least, let's look at our letter D. Letter D here, okay? So in letter D, you have a lot going on here, okay? We're asked to find x and y on this one. We're asked to find both x and y on this one. So we have a pair of vertical angles that we can use to find x. Vertical angles that we can use to find x. Okay, right here we have vertical angles with each other. They're opposites of each other. They make the x. So we can set them equal because they're congruent, because vertical angles are always congruent. Here x minus 5 is equal to x plus 15. We solve by subtracting x. 2x minus 5 equal to 15. Add 5. 2x is equal to 20. Divide by 2. X is 10. We can find the y's next. And to find the y's, we'll have to use the fact that they're a linear pair. They make that straight line together, okay? So we have y plus 20 plus 4y minus 15 equals 180. Add them together to equal 180, because a linear pair are supplementary, meaning they add to 180, so we'll add them to 180. Y plus 4y, we combine like terms since they're on the same side of the equal sign, gives us 5y. 20 plus negative 15, or 20 minus 15, is going to be plus 5, equal to 180. Subtract 5 away. 5y is equal to 175. Divide by 5. Y is 35. Well, you now have your homework. Go ahead and talk to Mrs. Schroeder and ask her to pass out the homework to you, okay? So as you each individually finish, go up and ask her for the homework. She'll give it to you. Sit back down, and please begin to quietly work on it, okay? I left her my answer key in case you need to ask questions, so that way she's able to help you out a little bit more, okay? This will be due on Thursday, so 2 days from now, okay? And what we'll also be due is our 1.4 assignment. Have a great day, everyone.